Namaste children. So do you remember in the last class we have seen what is the matter around us? Yes. Can you answer these questions? What are the different types of matter we have seen? Good. Solid, liquid, gas. How the matter can change from one state of matter to another state of matter? Yes, you are right. By changing the temperature and changing the pressure, we can change the state of matter from one state to another state. And what is evaporation? Good. That escaping of molecules, liquid molecules into the space without reaching to its boiling point is called evaporation. And whenever evaporation takes place, that body will get cooled. Evaporation is the cooling process. Now my question is, the solid, liquid, gas, are they made with same substances? Everything related to solid, liquid and gas and what do we see around us are made with same type of materials? The clear answer, we all say that no. Why? Because we see the different materials. When you see your bench, your glass windows, fan is made up of different materials. But all these materials, suppose you have taken the fan or bench, will all these materials made up of same type of particles? Is matter around us pure, means made with same particles? That is what we are going to see in this chapter. In this chapter, we are going to discuss mixtures and pure substances. Second, how to separate the mixtures. Third, physical changes and chemical changes. Fourth, some questions related to this particular topic we will discuss. Now the first topic we are going to see, mixtures and pure substances. Now let's come to the pure substances and mixtures. First of all, mixture. Your mother is trying to cook the food. Before pouring the rice into the bowl, generally a small thing she does. She checks any stones are present in that rice or not. Didn't she? So if any stones are there, she will remove those stones, unwanted material. What happened? This unwanted material is mixed with rice. Instead of calling it as pure, now something is mixed. Mixture. Another different type of material is mixed mixtures. Now, what about the other examples if we see in our day-to-day life? Morning we are getting the milk now from the milkman. He pours the water in it. We all know that. Water is mixed in it. And we are taking the food, the curry is mixing of so many different materials. Now, what is mixture? With different materials come together and mixed up, we will call it as a mixture. Now when you separate all these mixtures, remove all the different particles, remove. Now if no new material is there in it, if entire thing is made with same material, entire that particular thing. Suppose if you are taking the rice, if all the rice are there, then we will call it as a pure substance. Now we are going to discuss about the mixtures. There are two different types of mixtures. Homogeneous mixture and heterogeneous mixture. Take one glass of water. add sugar and rinse it and try to see it. If entire sugar is dissolved, we will see that that sugar is not at all visible to us. It's completely dissolved. Even by filtration also you cannot separate it. Such mixtures which completely dissolved mixtures are called as homogeneous mixtures. Heterogeneous mixtures, now add sand into the water, rinse it. You will see that entire sand changes, the water changes its colors. But take it cloth, fine cloth, and pour water in it. Now after different layers of filtration, you will find the water out. That entire sand can come out. It means the sand is not completely dissolved. Such not completely dissolved mixtures we will call it as heterogeneous mixtures. So, how many different types of mixtures we have seen? 2. Homogeneous mixtures means completely dissolved, unable to identify what is dissolved in it, homogeneous mixture. Second, heterogeneous mixtures which can be separated by simple filtration methods and other methods. Now, we are going to discuss about homogeneous mixture. What is homogeneous mixture? Just now we have seen it's completely dissolved and unable to separate it by simple filtration method, we will call it as homogeneous mixture. A homogeneous mixture is also called as solution. A homogeneous mixture is also called as solution. Now, as it is mixed with the two different materials, now one with of larger quantity, we will call it as solvent. And another one with minor quantity, which I mixed, I am going to call it as solute. Solute of lesser quantity, larger quantity, solvent. Now solute is dissolved in solvent and we got the solution. Come back to the example, salt water. How much salt we will add into the water? 1 glass full of water and tablespoon of salt. That small amount of tablespoon salt we will call it as solute. And more amount of the water we will call it as solvent. I mixed it. Solute plus solvent is called as solution. Solute plus solvent is called as a solution. Now in sweet water, what is added in what? In water we have added the sugar. Now the small amount of sugar I will call it as solute. The water I will call it as solvent. That sugar plus water is solution. Solute plus solvent is called as solution. Now in a day-to-day life we see so many examples that we see the homogeneous mixtures. Suppose in milk which we are taking, generally small amount of water will be added. Now you can see that milk is the solvent and small amount of the water is the solute. Alcohol, some amount of water or soda will be added. The larger one we will call it as solvent and the smaller one we will call it as solute. When we mix these two, we will call it as solution. You can get some other solution, some other examples also. Now I hope so that you understood. What is homogeneous mixture? Homogeneous mixture is called solution. And the smaller quantity we will call it as solute. The other one, larger quantity where we are mixing this one is called solvent. But the question comes, can I add how much I require that amount of solute in the solvent? No. Let me see some example. Take a glass of water, add 1 teaspoon of salt, rinse it. It is completely dissolved. Now again I added 1 more spoon. I rinsed. That is also dissolved. Now how much salt I can add like that continuously? Full 1 glass of salt? No. How much? to certain extent only we can add. So now if I am keeping adding on the salt and checking, you will find that after some time whatever you have added, it will not be salt and it will be settled down. Why like that? Because that water reached to the capacity and maximum extent of solute got dissolved. Whatever the extra is there, that is not get dissolving, is getting settled down. That particular maximum extent, where further amount of solute is not getting dissolved, we call that particular solution as saturated solution. Generally we say, no, I got saturated. Means from there onwards I cannot tolerate. Saturated. From there onwards you cannot add the solute. Different substances, different solutes will get dissolved in different these things. So that's why there is a definition called solubility. The maximum amount of solute that can be dissolved in 100 grams of solvent is called solubility. The maximum amount of solute that can be dissolved in 100 grams of solvent is called solubility. The solubility value changes from one substance to another substance. Now, I want to express this in terms of percentages. Percentage of the solute by mass, percentage of the solute by volume. Then the formula would be like this: percentage of the solute by mass, mass of the solute by mass of the solution into 100. Percentage of the solute by volume, mass of the solute by volume of the solution into 100. So these percentages generally, where do we see? If we go to the chemistry labs, on the chemicals bottles you will see the percentages will be expressed. That is very important. When we see the percentage, we can easily come to know that how much amount of solute dissolved in that. Generally in chemistry we use two different types of solutions: concentrated solution, diluted solution. Dilute means less amount of solute present in that. Diluted means more amount of solvent is there in with less amount of solute, and concentrated means more amount of solute in less amount of solvent. So those percentages of mass, percentages of solute by mass, percentages of solute by volume, these expressions generally we find in the chemistry lab. By looking at easily we can come to know that whether it is a concentrated solution or diluted solution. So we have seen about the solutions. A homogeneous mixture is called solution. Now second, heterogeneous mixture. Two different types of heterogeneous mixtures we are going to see now. The first one, suspensions, and second one, colloids. Suspension. The name itself is saying that the particles generally will be suspended in the medium or in the solvent without getting dissolved in it. Suppose we have taken the mud water. So take the water and add some sand in it and mix it. You will find that entire sand will be is spreading over entire this thing. If you wait for some time, what will happen? It will get settled down. And before till it settles down, you can find that entire one is spread throughout the medium without getting dissolved in it. Such solutions we will call, such mixtures we will call it as suspensions. And the other one, colloids, it's intermediate. It looks like solution, homogeneous mixture, but it is an heterogeneous mixture. It's a completely, seems that it is dissolved, but it is not dissolved. Example, milk and water. Generally we feel that completely dissolved, but it is not. It is not. The milk is mixed with water, it spreads throughout it, but completely not dissolved in it. Such things are called colloids. Yes, I learned from my teacher regarding one bird, swan. In Telugu we call it as Hamsa. This bird has the ability to separate the water and milk. If you give a milk to the bird where you have mixed the water, it drinks only the milk but leaves the water separately. Yes? As it is not completely dissolved, God has given the certain ability to that bird and it drinks only the milk from that heterogeneous mixture. So now we have seen three different types of mixtures. Homogeneous mixture called solution. Heterogeneous mixtures are suspensions and colloids. Now how can I come to know that this one is a solution, this one is a suspension, this one is a colloid? There is a simple test based on Tyndall effect. First of all, what is Tyndall effect? When light falls on any particle, that light will get scattered and we could able to see that particle. If the size of the particle is very small, can it scatter the light so that we can see? Mostly the answer is no. But imagine you are in a closed room completely filled with dust and all those things. On the top, one small hole is there. Through that, sunlight is coming. You will see the path of the sunlight. Why? Because light is falling on the dust particles. Those dust particles scatters the light, making that path of the light visible. That phenomenon we will call it as Tyndall effect. Even you can see the same phenomenon in the dense forest also. When light falls on this water droplets, you can see the path of the sunlight in the dense forest. That phenomenon we will call it as Tyndall effect. We are going to use the same thing now. Take three different solutions. One is solution, another one is suspension, another one is colloid. Now put the torchlight on one side. You will not see the path of the light in solution. You will find that the entire light came to the other side. And in suspension, that particular thing blocks like a opaque substance. The light won't flow that side and you will see the particles clearly. Here, the size of the particles in suspensions are very large. But whereas in colloid, you will see the path of the light in it. Why? Because the size of the particles in colloidal solution is that much of big enough, but not like in suspension, but smaller than suspended particles, but more than the dissolved solution particles. That intermediate size of the particle will scatter the light to the other sides, so that the path of the light visible in the colloidal solution. So, if path is visible, that is the colloid. If path is blocked, that is the suspension. If path is invisible, that is the solution. So by using this torchlight experiment, we can identify the solutions, suspensions and colloidal thing. So in this particular topic, what we have learned pure substances and mixtures. Mixtures are of two different categories: homogeneous mixtures and heterogeneous mixtures. Now, in the next class, what we are going to see is, we are going to see the separate methods to separate the mixtures. Okay? Now, let me discuss what are the topics we have seen in this particular chapter. Topic. First thing, what is pure substance? Second, how many different types of mixtures we have seen? Third, what is solution? Fourth, what is solubility? Fifth, how do you find the percentage of the solute by mass, percentage of the solute by volume? Next, what is suspension? Next question, what is colloidal solution? And the last question, Which activity will help us to identify the difference between the solution, suspension and collide? I hope so that you understood this topic. Thank you.